This is a diversion to our study of pigments in a French watercolour. Now, my videos are in the real world of pigment identification. I don't know what's coming next. And we are diverting into an interesting anomaly with XRF, X-ray reflectance, and FORS, that is, using a fibre optic reflectance spectrometer. You may remember the white pigment on the French watercolour. Now, XRF showed PB and AS, so we have lead white, but also a high silica reading and phosphorus. However, the UV reflection is pure white, and we normally get a mauvish tinge with lead white. So using FORS could be interesting. The top bluish spectra matches the yellow CHSOS spectra for chalk. So we can be fairly certain that the white is in fact a mix of lead white and chalk white. And there's just a possibility the artist has used a gesso preparation, but unlikely, as we would expect it to be used as a ground covering the whole surface. So we divert to another white pigment conundrum. If we look at the white area in this work using FORS, we get a distinctive zinc white spectra. And you can see it's a perfect match with the CHOS example. It would not be unreasonable on this evidence to pronounce the pigment as being zinc white. However, a professional laboratory identified the pigment as lead white, with a minor addition of zinc white. So let's look at the XRF to see what's going on. And here we see a very strong PB count, and the zinc count is about a 6. So we have lead white with zinc white. So to conclude, we need to use both XRF and FORS to examine pigments, especially mixes. And, interestingly, we are also obtaining an insight into how the artist worked. For example, it is less common to mix 2 types of white pigment. And this, of course, can be very useful for attribution purposes. I hope you found this interesting.